Hey there, scientists! Today we are going to develop a model and think like a scientist. You are going to develop a model to describe the movement of matter among plants, animals, decomposers, and the environment in which they live. So first, we have to think back to what we've learned about the cycles of matter. So if we recall, we have talked about different cycles. We talked about the carbon cycle and the nitrogen cycle. And we have talked about how matter and energy cycles through a system in any environment, in any ecosystem. And we've talked about that cycle of how the energy moves from one source to another. And you are astutely aware that all energy starts from the sun. Now, when we think about these energy cycles, we have to be reminded that anytime we're looking at these cycles, we'll notice that those arrows show where the energy is moving to when it moves through any of these cycle systems. We have studied to this point the words producer, consumer, decomposer. We have talked about microbes in the soil. We've talked about the air. In previous grades, you've talked about how other parts of the environment would include like the weather and the precipitation. Those are all parts of the environment. Well, when we're building a model here, we're going to need to build a model that includes all of the elements of an environment and a system that explains how things cycle, how matter could cycle, energy could cycle through an environment. So we always have to start with the sun because that is where all of our energy begins. And then if we recall back to everything we have studied so far, what is the process that takes carbon dioxide from the air? Yes, it is photosynthesis. And how is carbon dioxide returned to the air? Yeah, if you remember correctly, it's when animals exhale that carbon dioxide that carbon dioxide returns to the air. So this would be part of the oxygen cycle and part of that carbon dioxide cycle. It's a very general model of the carbon dioxide oxygen cycle, and it is one that you could replicate in your work this week because you will make a model of a cycle of matter that takes place in a real ecosystem. You're going to be using some of the resources that you have available, especially through our library, and we have easy access to those digital library resources in order to do some research to find out how energy or the other cycles how matter flows in different ecosystems or different environments. When you complete your research, you will make a model of a cycle of matter and you're going to share it somehow. You might be sharing it with your classmates. You might be sharing it with a teddy bear at home. You might be sharing it with a friend. You might be sharing it with a video recording for your classmates to watch independently. But you need to be prepared to share your model and explain the work that you did that went into it. So when we develop a model, we have to remind ourselves that ecosystems are made up of the organisms and non-living things in an environment. Materials are constantly moving around these different parts. You can develop a model to describe this movement of matter. So the first thing we have to do is you're going to ask yourself a question. You're going to ask yourself a question like a scientist. How can you develop a model to describe the movement of matter among plants, animals, decomposers, and the environment? And remember, that is your driving target this week. That is what you have to be able to do. Well, the first thing you're going to do is you're going to research an ecosystem. So you will select an ecosystem for your model. Will it be a small ecosystem, such as a pond, or a big ecosystem, such as a pine forest? Use reliable reference materials to discover how materials cycle through that ecosystem. Decide which cycle to show. Where do the raw materials for the cycle come from? Are they in the air, water, or soil? How do the materials taken in by living things? How do the materials move among different organisms? What happens to the materials when organisms die? Record all of your findings in your science notebook. Your model should show maybe one of the two nutrient cycles that we talked about earlier. Maybe the carbon dioxide oxygen cycle or the nitrogen cycle. But your model must show different plants and animals from the ones that we have studied. So you will see in my model that I demonstrate a prairie landscape. Since I am taking the prairie ecosystem, you cannot. You will need to select your own ecosystem that is different than the one that we have studied in our textbook and the one that I made for you. But you can totally model it off of the work that I've done. Maybe you want to choose the African savanna or a forest or a river or a stream. Maybe you want to go back to some of the things that you studied from 4th grade, like the Sonoran Desert or the Florida Everglades. You can reference any of the things, the ecosystems, the environments that you know well to make your research easier. All right. Now that you have your research done, you will assemble your model. What are you going to use to make your model? How will you show the direction that matter moves through the ecosystem? Include labels to show what is happening in each part of the cycle. So make sure you have those labels and you're ready to explain the process for when it comes time to present. Now, some of you are going to make your model using a digital platform, maybe in Google Slides, maybe in some other digital element that you feel comfortable with. Some of you are going to hand draw it. And some of you, I know, are going to build your model off of the food chains and food web that you made previously. And that makes sense to me. However you do it, you need to be prepared to present and share your intelligence. So after you assemble your model, there's time to analyze and revise. So think back, look at your model again. Does the matter keep moving through a cycle in your model? If not, where does it stop? What would happen if matter stopped moving through a cycle? You can use the internet or other resources to research more about producers, consumers, and decomposers in the ecosystem you selected. Choose one producer and one consumer to add to your model. Indicate in your diagram how they fit into the cycle in your model. And then, of course, that last element is to present. When you are certain that you have made the best model you can, present your model cycle to your class. Again, many of you are going to present this in multiple different ways, so you will have to talk with your classroom teacher on how they want it presented. And it might just be that they want you to present it to your own family. So be prepared to present to whoever is willing to listen, if that is your favorite pet or your favorite stuffed animal or your brother while he's asleep. Point out how the non-living materials pass from organism to organism and among the non-living things in your environment. When you present your model, you should be prepared for the questions like, which cycle of matter does your model represent? Which part of the non-living environment is involved in the nutrient cycle? How do materials pass from organism to organism? What is the role of decomposers in the cycle? Be prepared to answer all of those questions when you present. Be prepared to answer the question, in what ways did you think like a scientist as you completed this activity? You will have some questions that you need to answer as you build your model, like what was the environment you selected? What is the producer in your food chain? What was the first consumer in your food chain? What is the second consumer? What is the original source of energy for all of the organisms in your food chain? And those are questions that we have been evaluating since we have started on this life science quest. And as you think and work like a scientist, make sure that you have done the research to build a model so that when it is all done, you can confidently say that you can develop a model to describe the movement of matter among plants, animals, decomposers, and the environment. Until next time, scientists.